Hi, welcome to the video. Here's a probability question involving a test, or a quiz. So we have a quick quiz consisting of a multiple choice question with 4 possible answers, and then another multiple choice question with 5 possible answers. And a student is planning to randomly guess the answer to both questions, and we want to find the probability that both responses are correct. So if this was your whole quiz with 2 questions on it, what would be the problem you'd get a perfect score if you just randomly guess at the answers? So let's break this up into a couple of events here. So we have, we're looking for the probability that both responses are correct. So we see that word both, that's indicating an and probability. It means the first response and the second one. So we get the first correct and the second correct. So we're looking for the probability that the first answer is correct and the second is correct. So we notice that and probability, so we're hoping that they're independent events. We read through the story and see, is there anything that indicates that my answer on the first one would, whether or not it's right, would be independent of whether or not my answer on the second is correct. And we see this keyword random. So because I'm guessing at random, we don't expect whether I'm right on the first one to have any bearing at all on whether I'm right on the second one. So we can say they're independent events, so we can break it up as the probability that the first is correct times the probability that the second is correct. And note that's only because we were told they're independent events. Now we want to go through and find each of these probabilities separately. So let's use a different color and focus in on that first problem. So the probability that the first is correct, we can think about this as the number of ways to guess the correct answer divided by the number of ways to guess. So the number of correct guesses divided by the total number of guesses. And let's fill those in. So the number of correct guesses, well, it sounds like there's only one right answer to any question, so there's one correct guess you could make. How many choices did you have when you guessed? For question 1, there were 4 possible answers. So that's the total number of guesses you could make would have been 4. So there's a 1 in 4 chance that you're going to guess correctly on the first question. Now let's look at the second. For the second question, there's still just one correct answer. But how many possible guesses were there, or possible answers we could have chosen? Now there were 5. So for the second question, there's a 1 in 5 chance that you guess correct. So when we calculate out this, the probability the first is correct times the probability the second is correct, we're going to be multiplying the number 1/4. That's the probability of guessing correct on the first one, times 1/5, the probability of guessing correct on the second. When we turn that into a decimal, we get to a fraction, it's 1 in 20. So there's a 1 in 20 chance you'll get 100% on that quiz. The answer here is asking for a decimal, so we're going to divide 1 out of 20, and that turns into 0.0. If I can get you right, turns into 0.05. Notice they ask for a percent, so we slide the decimal over 2 places, and we say there's a 5% chance that you could get a perfect score on this test if the test had 2 multiple choice questions, one with 4 answers and the other with 5, and you guess at random. Well, 5% of the time you could hope to get a perfect score.